This forum is focusing on the excellence of STEM teaching, and we're privileged today to have 3 young people who have developed some of the best school STEM projects in the States and have gone on to represent Australia at the Intel International Science and Engineering Fair. My name is Stuart Garth, and I've had the wonderful task of working with and preparing a lot of these students for ISEF, and at times travelling with them to the USA. I'd now like to introduce the 3 young people. On the left, we have Marianne Poyitt, then we have Lachlan Bolton, and then Lucy Lake. I'm going to have a series of questions. We'll start with each person at a time. At some point, I'll get you to ask questions, and then we'll ask some more questions of the students. So it'll be a bit of an interactive panel, so you can just kind of put up your hand at a time when I say, and you can ask us questions. So I'll firstly start with Marianne. Marianne, in what year did you take your project to the International Science and Engineering Fair?
So I went to ISEF in 2017.
And where was it held?
Los Angeles.
Right. And how did your school help prepare you for that?
So I did it as part of my Year 10 science project. So we had the teachers in the school helping ensure you were keeping up to date with what you were doing and that you were okay and you hadn't hit any brick walls with what you were doing.
Great. Okay, I'm going to pass it to Lachlan. So Lachlan, when did you go? So Marianne went in 2017. When did you go?
2018.
Where was that held?
Pittsburgh, Pennsylvania.
So how did your school help you prepare for your project?
So my project was a part of my Year 12 Design Technology major project, and so I had my Design Technology teacher who was very supportive throughout the whole process, but also science teachers, technology teachers around the school who provided support throughout the project.
Great. And Lucy, when did you go to ISEF?
I was 2019 and I was at Phoenix, Arizona. And your last question, saying mine was a DT project, and my teacher was an absolute legend and encouraged me to enter it and gave me all the resources and help to help me get there. Yeah.
Great. Okay. We're now going to explore more what were your projects about. So Marianne, can you firstly start, what did you actually do for your project?
Sure. So I did a plant survey on a neighbouring reserve to the school that I was attending to look at what influenced which plants grew where, because the school was involved in a regeneration project of a riparian corridor that had been destroyed.
Right. So the big question is, how many hours did you perform that experiment in school time, and how many hours was out of school time, would you say? Or as a percentage?
Okay, yeah, that's hard. So probably 80% was out of school time. I did 2 whole days of data collecting, and then a lot of it was analysing that and trying to find the relationship. And majority of what I did in school time was writing up the report. And so, yeah, that was basically it, because it was a plant-based project. You can't really do that in school time.
Right. Okay. One more question. We talked about teachers. Do you have any mentors you reached out to?
Yes, so I had a mentor who was doing a university degree in biology, and so he helped me in the research I had to do and understanding what I should be doing in the project to get it of a professional standard.
Great. Okay. Lachlan, can you talk about your design project?
Yeah, so my project was a modular surfboard. So for all those who aren't familiar with that side of the surfing sport, surfboards can be big, they can take up a lot of space in the car, and I had an issue where each week travelling to the beach, the surfboards took up a lot of space, so I wanted to solve a simple problem and create a modular surfboard that can fold in half, making the trip easier.
All right. So how much time did you said it was your major Year 12
major design technology
project. So were you able to do everything at school, or did you have to do work out of hours?
I would say probably 80% of the project work I could do in school, which was like the design process, physically building the board, but I did have to go outside to seek advice from industry leaders, and some work I did do outside because the process of building a surfboard, you can't do all of that in a school setting, but yeah, mostly in school.
Okay. One question I need to ask to you. You did your project as a D&T project. Did you have to modify it to you entered yours into the Young Science Awards organised by the Science Teachers Association?
Yes.
Did you have to do extra work to enter that?
No, I basically submitted it to in the HSC and then submitted exactly the same thing to Young Scientist.
Great. Did you have any mentors who helped you along the way?
Yeah, obviously my design technology teacher supporting me throughout the whole process, teachers from the school, but also I did seek advice from a few surfboard designers in the Northern Beaches area to support me and to give me advice onto how I can design the system of breaking the board in half while still maintaining the strength and that a surfboard has.
Did you do any testing of it?
Yeah, so a big part of the design process was, once I finally got a prototype together, testing how much strength the board could take relative to a normal surfboard. So I sought out a company called Siebel, which make a lot of plastic chairs for schools, and they have a laboratory where they have machines which stress test all the chairs. So I was able to take a whole lot of surfboards there and physically test how much weight the system could take.
Okay, what about, did you actually physically go out on the waves and test it out?
Yeah, obviously that was the final step, taking it out to the beach and testing it.
Was it just yourself, or did you get other people to have a go?
Yeah, I got a couple. The final stage of my design process was getting surfers who live on the northern beaches, professional surfers as well, to test out the board and give me advice as to how it compares to a normal surfboard that's not broken in half.
So, Lucy, can you tell us about your project?
For my project, I redesigned and created rowing oars with inspiration from the tubercles on whales' fins. So like the whole premises was about how you can use biomimicry to enhance your design, improve performance, and yeah, it was really, really fascinating, yeah.
So, okay, so you say you designed a new oar based on biomimicry. So what sort of animal did you base it on?
The whale.
The whale,
Yeah.
the whale fin. How did you test the water fluid dynamics of all that?
So I did computational fluid dynamics. So that took quite a bit of time to learn. I made all the oars with carbon fibre, and then similar to Lachlan, my final stage was going out and testing the oars on the water.
Okay, so how did they perform?
It went well, but one broke actually, so I had to remake another oar. But yeah, it was really rewarding to get to test what you've made and see how it actually works.
Great. Did you have any mentors help you on the way?
Yeah, I had Ollie Nichols. He was actually in Lachlan's group that went to ISEF, and he ended up winning the whole contest. And he went to my school, so there's another factor that made it easier to kind of get into like STAN New South Wales and BHP, because we'd already had someone from our school who'd experienced it, so the teachers knew like what had to be done, when things were due, what they're looking for. But yeah, it was awesome to have him there to kind of give advice, especially on the speaking side and your presentation and posters and things that you need.
Great, thank you. Yeah, so in the year that Lachlan went over to the US, 2018, you've got to imagine there's 1,800 students from all around the world, 80 countries, presenting their projects, and they have lots of awards. They have first, second, third, fourth grand awards. There's 22 categories, so you might be in maths, it might be in physics and astronomy, it could be on animal science. So what they do, they select the winners. They start with fourth place, third place, second place, and first place. Now in Lachlan's year, there was a boy named Oliver who designed a drone which was a window cleaner. So for skyscrapers, you'd be able to just attach it to the top stanchions and it could automatically clean all the windows. It was quite an amazing machine, and he put his into the category of robotics. It got first in his category around the world. They then had the top 22 categories winners sitting on the stage or standing on the stage when they then announced the overall winner in the world, and he got first place and won $75,000 US for that award. And so, yeah, it's interesting to know that that was just a straight design technology project he did for his school, and that went on to be the best prize in Australia. We did get some coverage. We tried to get coverage when we returned, so he's on all the major news programs, and so, and I think he's gone on with that as well. He's doing mechatronics at the moment, so he's in that field. So we've had some really good results, including the three who are both here. Now, next question. We want to now know, okay, you did this project. Now we now want to look at the impact of that project on yourselves, what you're now doing. So I'll start with Marianne firstly. So if you can answer this question, please tell us what kind of impact your school project had on your future. I know it's only 4 years, a short future. For instance, did your STEM research at your school lead you to follow any specific pathways when you left school, or did your project open up any opportunities for you?
Yes, so in Year 10, obviously, I didn't really know what I wanted to do when I finished school, but experiencing the whole writing the report, doing the investigation for science, I definitely loved it. I wanted to follow that, and so I'm currently doing a Bachelor of Science, and I use the skills that I learnt for report writing all the time. So I have done research on genetic mutations and how to identify them, how to create a screening test for some cancers. I've used it for conservation biology techniques. So I literally use it all the time at the moment, especially even the techniques of measuring diversity that I specifically used in my project, I'm doing in my capstone units at university. Okay,
so can I just ask, what career are you looking towards for your university course?
Sure. So I'm doing a majoring in mathematics. So I'm aiming towards becoming a maths teacher so that hopefully I could mentor other people in what they want to achieve in science and STEM.
Great. Okay, next question. When doing your project, and this is a big factor we've been looking at today, you picked up a lot of STEM skills. How have you gone on to use those STEM skills, not obviously for your project, but just for general life? Is there any of those skills you've been able to take on?
Okay, yeah, so I'm doing the Bachelor of Science, so I literally use them in all the assessments that I'm participating in. And even, I know one of the big things that we were all talking about is ISEF. You've got to just speak to whoever is put in front of you. And so that was a major thing I built in public speaking and being able to communicate your ideas to those people.
Great. Have you had a chance, okay, you went overseas, you were given a lot of assistance and support. Have you had a chance to kind of give back to any other student since that time to be a mentor yourself?
Yeah, absolutely. So my school approached me about talking to the Year 8 technology class and who had to do a major project in something, and so I talked to them about my results, and in the end they took it on board and went and regenerated part of the bushland according to what I found, to compare it in future years to see how well that all worked.
Great. Well, thank you very much, Marianne. Thank you, Lachlan, and thank you, Lucy. Great.